So we are going to do a little bit more work with proving trig identities, maybe give you some different strategies. Right now we've done the get everything into sines and cosine strategies. We're going to do a little bit more. And we've done a bunch of just trying to simplify. The difference with proving trig identities is you're going to have something like an equation, kind of like this first example down below. And typically what we need to do is make one side look like the other. This is what this is saying right here. With an identity, you begin by writing down one function and end by writing down the other. In other words, if this is where you're starting, that tells you where to stop. So I'm proving that the left side looks like the right side, or you could prove the right looks like the left. All right, what you don't want to do is you don't want to meet somewhere in the middle. I wouldn't take a look at this problem and I wouldn't solve for something in the middle. I would solve and make this look like 2. And we're actually going to go through this example and show you, we've done this with algebra, why this would simplify down to 2. So if I'm starting with this first on the left-hand side, I can take a look at the numerator and I can say, well, that's going to split up into x minus 1 and x plus 1 if I were to factor that out. Keep my denominator of x minus 1. Okay. Same thing with my numerator on my second fraction. It's still going to split up into x minus 1, x plus 1, and then it's all divided by x plus 1. Now, keeping in mind, I'm only working with the left side. So I'm trying to make it look like 2. I know my answer should be 2. So I'm able to reduce out the x plus 1 in the second. I'm able to reduce out an x minus 1 in our first fraction. And then what I'm left with from our first one is just x plus 1. And from our second fraction, I have minus, so watch your signs, x minus 1. Because keep in mind, this is telling us I need to subtract both the x and that negative 1. So by doing that, so I have x plus 1 minus x minus a negative 1. So again, simplifying, I can see the x's, positive x, negative x, those reduce out. And now I'm just left with 1 plus 1, which is 2. So we've started with the left side, done some reductions, simplified it out, gone to the right side, got it to look like 2. Okay, so that was our basic general strategy. So start with the expression on one side of the identity. The proof ends with the expression on the other. Again, this is key. Proof ends once you're on the other. Don't meet in the middle. The proof in between consists of showing sequence of expressions. So it has to be easily seen. It can't be some mathematical kind of, I'm going to make this great big jump. Like, we should be able to see what's going on. All right, so trying this now with some trig. Starting with the left, making it look like the right. Our basic step is start with sines and cosines. So I'm going to switch tangent into sine of x over cosine of x. I'm going to switch cotangent into cosine of x over sine of x. Okay, so I have fractions, I need to add them. In order to add fractions, I need a common denominator. So how about cosine times sine? And I'm going to keep them separate for now, just so I can see the work that's happening. So whatever I have to multiply the bottom by to get the common denominator, I do the same to the top. So that looks like I had to multiply it by sine of x. So I multiply the top by sine of x, and we get sine squared x. Okay, same thing on our second fraction. I had to multiply the denominator by cosine of x, so I multiply the top by cosine of x, and I get cosine squared x. Okay, they have a common denominator. I'm now going to join them, and I'm going to combine my numerator, so I have sine squared x plus cosine squared x. And I'm hoping that looks familiar. That's a Pythagorean identity. We had this in our last section where we had sine squared plus cosine squared equals 1. So that means I can go back here and say that reduces down to 1. Okay, so now I have a fraction that looks like 1 over cosine times sine. And I can split this. So I could actually write this as 2 separate fractions. As long as you remember your properties of fractions, you can tell yourself when you multiply fractions, you're multiplying tops with tops, bottoms with bottoms. So it's the same thing, just a different form. And now it should be easier to see, well, 1 over cosine, that's really secant of x. And 1 over sine, that's really cosecant of x, and you've just proven your identity. So we've started from the left-hand side, we've moved over to the right-hand side, and we've proven it. Okay. A different strategy. Maybe you're looking at something and saying, I'm going to work with the more complicated expression and work towards the less complicated. In this case, it's still going to be starting at the left, working with the right. Again, if nothing else gives you an idea, you can convert the entire thing to one involving only sines and cosines. That's always a go-to. Okay, make sure you combine fractions by getting a common denominator. This is huge, and I feel like this is where people try and make a shortcut. It doesn't work. Okay, so you need a common denominator. So again, that's our start, our go-to for this first one. So we're going to have a common denominator. And when all else fails trying to make the common denominator, remember, you can always multiply them. And that's exactly what we're going to do. Okay, so again, I'm going to keep it separate for right now until I can see what's going on. I know it's kind of like, oh, this is a lot of work. It's worth it. Trust me, it'll make it a little bit easier to see. Okay, so whatever we multiply the bottom by, which is secant of x plus 1, I multiply the top. So here's secant of x plus 1. Same thing. Whatever I multiply my denominator by, I have to multiply the top. So I multiplied it by secant of x minus 1. Okay, so we're going to combine. And if I'm looking at this denominator, my hope is right now, I can see if I were to factor this, or I'm sorry, distribute this through, this denominator is really going to turn into secant of x, secant squared of x minus 1. Right, so if I multiply the first, that's where I get my secant squared. My outside is positive secant, inside's negative secant, so that middle term drops, and my last gives me a negative 1. Okay, combining the numerator. So I have 1 secant of x plus another secant of x, that's going to give me 2 secant x's. I have a positive 1 and a negative 1, that drops out. Okay, so again, my hope is maybe this denominator is ringing a bell from our last unit. We had a Pythagorean identity that looked like this. And I can turn that Pythagorean identity by subtracting 1. So now it says tangent squared theta is equal to secant squared minus 1. And that's exactly what we have down here. So I'm going to replace this with tangent squared theta. Okay. So what I'm going to do now is bring this over here, and I'm going to kind of separate this a little bit. So I have 2 times secant of x, and I'm going to write this right now as times 1 over tangent squared of x. And keep in mind, when you're multiplying fractions, again, I can do tops with tops and bottoms with bottoms. So this is all the same thing. I've just kind of separated them. And my train of thought for that is, well, I see the 2, I want the 2, so that's good. I see this tangent squared x, and I see it's a 1 over tangent squared of x. So that makes me think, well, I could switch that, and that's really, I'm jumping over here, going to be cotangent squared of x. Those are equivalent expressions. Secant of x, I know, is really equal to 1 over cosine. Okay, so I'm going to keep going. So remember, when all else fails, get everything into terms of sines and cosines. So I have this guy. We're going to turn this one into sines and cosines. So I have cosine squared over sine squared. So now I can reduce again. So I see I can reduce out one of the cosines. And now let's see, what do we have left? So what we have left right now is a 2 on the top. I have a cosine on the top, and I have sine squared. So I could actually write that as sine split. Because sine times sine gets me sine squared. But the reason I did that is because what do I know about cosine over sine? Well, that's my cotangent. What do I know about 1 over sine? Well, that's my cosecant. So I've just proven that identity. I now have 2 cotangent x, cosecant x. And we're done. So sometimes you also have to use where you're going. You have to use that idea of this is what I need to make it look like to kind of help drive what am I going to do. Maybe it wouldn't have been so obvious back here to think I need to take sine squared and split it up into 2 fractions. However, doing that gets me that cotangent, gets me that cosecant, gets us our final answer. Okay, another strategy that we have is, now this one's kind of tough. It's already in sines and cosines. I can't really say one is more complicated versus the other. However, what I sometimes do is I'm looking at my end result as 1 plus sine, which looks like this, but it looks like it's the conjugate. So that may give me an idea to say, well, let's take this. Okay, so that's my original, but I'm going to multiply this by the conjugate. So 1 plus sine of t over 1 plus sine of t. So notice what we're doing. This really is a fraction equivalent to 1. It's not changing the value, it's just going to change the way it looks. I can always multiply anything by 1. Okay? So simplifying this, simplifying the denominator, same idea here is like what we had up above. This is going to simplify to 1 minus sine squared. I'm going to keep my numerator separate just for now. And the reason I'm doing that again is I'm using this final answer to drive where I'm going. I want a 1 plus sine t in my final answer. I have that 1 plus sine t. I have an extra cosine. I want cosine to go away. So that would make me think, what can I do with this denominator? Well, here again, there's that Pythagorean identity that we had. There's your sine squared plus cosine squared equals 1. And right now I have 1 minus sine, so if I were to subtract that sine over, now I know that that denominator is equivalent to cosine squared. So I'm going to do a substitution. So this is really equivalent to cosine squared. But now I can see in my numerator I have a cosine, which would reduce out with one of those cosines that we just found, and I have my final answer. So I have 1 plus sine of t left in the numerator, and in the denominator I have cosine of, oops, sorry, that should be a t. So again, using your final answer to help drive where you're going. Different strategy is to think multiply by its conjugate, make a fraction out of that conjugate. And our last one, this is a challenging one in the fact that what I would tell you is to, sometimes you got to work with the left and work with the right and find a place in the middle. And you can do the work on the side, and I'm going to try and number these so that we can follow our steps as we're going through here. So very first thing is I am going to recognize I'm working with cosecants, I'm working with secants. It looks like everything's in terms of secants, cosecants, and nothing is in terms of sines and cosines. So I may not do that initial turn everything into sines and cosines. Rather, I may look at that and say, again, I have a Pythagorean identity that we know. And I'm going to see, can I do some sort of a substitution? So if I subtract over the 1, I can see cotangent is going to be equal to cosecant minus 1. Okay, so in our numerator, I'm going to do our first step. I'm going to say that this is cosecant theta minus 1 over 1 plus cosecant theta. And then I see, well, that numerator could, I could factor that out into cosecant theta minus 1 and cosecant theta plus 1. And divide that all through by 1 plus cosecant theta. So that's cool because now I can see that reduces. And so now I have something that's going to look like cosecant theta minus 1. And now I'm looking at my final answer going, great, I did a bunch of work, and now I feel like I'm stuck. How in the world am I going to get that to look like my final answer? So I'm just going to put like a little star here. This is where I'm going to stop for a minute. And a strategy would be, okay, so now let's go to this other side, and I'm just going to do some work. This is just my thoughts. This is our work. And our work is, let's work on the right-hand side and see what happens. Keep in mind, I can't work from the left and work from the right and meet in the middle. I can work from the left and go to the right. So this is planning. So I'm going to take cotangent, and I'm going to turn that into cosine over sine, because remember, that's always a good strategy to use when you're stuck, when you don't know what to do. Secant, we have 1 over cosine. And tangent, we have sine over cosine. So I can see this is going to simplify if I rewrote that. That's really going to be the fraction 1 minus sine over cosine. Okay, so that's kind of cool because, again, I can see that these are going to drop. And now I have in my numerator 1 minus sine, and in the denominator over sine. So I can split this up into 2 separate fractions. Okay, just again, you got to remember your fraction properties. As long as I have common denominators, I can write 2 separate fractions. So 1 over sine theta minus sine theta over sine theta. This is an equivalent expression to what we have up here. But I know sine theta over sine theta, is 1. And I know 1 over sine is really cosecant minus 1. So what we have right here is cosecant theta minus 1, which is pretty sweet because that was where we got stuck. Okay, so how does that help us? Well, so now we have our proof. We just have to write this proof backwards. Okay, so I'm going to start with where we left off. I started here. My next step would be, okay, so I'm going to turn that into 1 over sine. I'm going to turn the 1 into a sine over sine. Okay, so we're going to work backwards. So that means my next step in this proof would be write it with a common denominator. So 1 minus sine theta. And now here's where it gets a little funny, because this is the part where maybe you wouldn't see this. Maybe you wouldn't think multiply through by a cosine. But I did this proof. I know that I could do that. I'm multiplying through by cosines. It's just where I'm putting the cosine. So perhaps just for ease, you're going to write down this step up above because you've shown me the work. You've shown me this is what's happening. It just, again, it might not be that obvious to you if you were to just only work from the left side that you need to multiply through by cosines. Okay, so then we go to the step up above before that. So let's see what that was. That was saying, okay, I'm going to multiply through by cosine over sine and expand that out. So here's my next step. We have cosine over sine. And I'm going to split this up. So I have cosine, and then I have minus sine over cosine. So again, all I'm doing is splitting this up into 2 separate fractions. And then let's turn it back to what we have. So we have cosine over sine gives us cotangent. 1 over cosine gives us secant. Sine over cosine gives us tangent. And we have now proof. And we are now at the end. So work from the left, go to the right. If and when you get stuck, work from the right and make a plan. But then you're just going to bridge the gap and work backwards. Okay, we're practicing this more in class. This is always a good reference video to go back to. So when you get stuck, perhaps rewatch even this one to try and give you some ideas of how to do some of these harder proofs. Okay, I hope you guys have a great day.